This is a centrifuge, a medical grade one. What a centrifuge does is that I believe it takes two different, or it separates materials. So say you put a blood sample into this, it would separate the plasma from the actual cells from blood or oxygen. So you insert this into the device and it just basically spins it around until it separates the material. This is a design that was done by the BioHack Academy as well. Basically, you just switch it on and adjust the knob to see how fast it would go. You can close it, leave it. It has an Arduino usually built into it so that you can measure how long it goes for. It lets you know when it's done. So.
What are all those pieces that are embedded into the design?
Oh, so like you have your LCD screen to explain the speed and RPM that it's going. It'll tell you how much time you have left or things like that, or how long it's been going for, things like that.
Mm-hmm.
So.
And what's on the inside?
So inside, the motor is controlled by a microchip. So the microchip is embedded with it. So you have your pins to go to your Arduino, which is basically a microchip or a little board. You would find a lot of these boards in everyday items such as your phone or anything like that. The Arduino is just made so it's a bigger size and more workable, so you can kind of mess with it, hack with it. And then you have your power inputs for the actual motor that spins the entire centrifuge.
What kind of motor is on the inside? Is that another one of those computer fans?
No, this one is a lot heftier, which I can't even pull it out because it is hard. It is an 810 kilovolt motor, so it has some power to it. It can spin a lot faster than a computer fan, though there's absolutely no reason why you can't use a computer fan either. So it just might not spin fast enough, but eventually it'll get the job done.
So how would you hack this?
For this one, this was probably the toughest project that I had to work with. What I would hack on this is simplifying the components on it. As much as I like having the LCD screen and everything in there, it's not really easy to pull together, where it's really simple to just even set a timer right by it. If the BioHack Academy is all about ease of usability, then we really need to emphasize the ease of usability, including just really simplifying things. There's absolutely no reason why you can't just put a timer right by it, or just have a timer separate from it that just connects to something that's already built, so that you're not having to build everything from scratch up.
So this part here, these tubes have to be kind of perfectly balanced for this to spin properly and to actually work to separate the DNA and purify it in the sample. So what they taught us to do in the BioHack Academy was to use another 3D program. I don't know if you ever saw that. I'm trying to remember what the name of it was, where you programmed by almost like by mathematical formula or by writing a computer code to say, okay, draw this shape of this exact size, then put this hole, then transpose that hole.
Right.
I mean, I guess a little bit like Grasshopper, but it wasn't Grasshopper that we used. It was a free program. So that was, I think part of that is that they wanted us to learn that program, but it was also because this needed to be so precise that it was actually an easier way to draw it than trying to draw it in SketchUp.